Hi everybody, I'm Arjun the Great, back at you with another science video. In this video, I plan on revealing the sun's dark secret. And, basically revealing the sun's dark secret. So everybody thinks of the sun as a friend, unless you're in the desert and you're dreading the sun because it took all your water away. So, the sun is a pretty vital role in the ecosystem. It paves the way for photosynthesis, and it helps all the animals in some way. And even that sun follows the quirks of quantum mechanics, a really weird range of physics. And I just wanted to mention everybody's fans of the sun. I have a poster of the sun behind me. I'm not sure if you have a poster of the sun in your room, but I just feel like everybody likes the sun a lot. But anyways, back to the topic. The quirks of quantum mechanics that the sun follows is called quantum tunneling. And it actually plays a really vital role in making the sun shine. So everybody knows that the sun shines because of a process called nuclear fusion, where protons, hydrogen nuclei collide and form a helium nuclei. And this process happens for a really long time. The sun's been doing this for about 5 billion years and will continue to do it for 5 billion years until it shrinks down to a neutron star and eventually just vaporizes. So this process basically just involves 4 protons colliding and forming a helium nuclei. And as they keep colliding, they keep forming new elements. So helium might collide into lithium and so on. And this process keeps happening until it comes down to iron. Iron is element number 26, and it's really heavy. So by the time the star starts fusing iron, it would have been old. So it's basically just an old star. So let's put this in a comparison. It's kind of like asking an old man to lift a 1,000-pound weight. And, well, that's not possible. So eventually, gravity comes in and shrinks the star, because the outward force is the nuclear fusion and the inward force is gravity. So gravity compresses the star and then releases it, and it forms a supernova. And other times it forms a neutron star, a black hole, a white dwarf, whatnot. So that's what happens. But nuclear fusion shouldn't be possible, because as you might know, 2 particles with the same charge don't want to attract each other. So I said that the star fuses protons together. So protons have the same charge. They have a +1 charge. And so according to the general theory, when these 2 positively charged particles try to fuse, they should repel each other, because they shouldn't attract. Only opposite charges attract, same charge repel. So I can kind of demonstrate that by using these 2 magnets here. So if these 2 are hydrogen nuclei, then this is a simulation of what happens. So they're kind of like repelling magnets because they have the same charge, the same poles. You get it? So yeah, pretty much it's basically just a game of chase. They're all sending hate messages to each other, and they don't want to attract. So then, how does the sun shine? How does nuclear fusion happen? And how does the sun live? Well, that's where the quirks of quantum mechanics comes in. So quantum mechanics has a lot of weird phenomena, and probably one of the weirdest is particles able to cross barriers like phantoms. So scientists usually call obstacles in the course of your path as energy barriers. So let's just say that this is an energy barrier, right? Because you need some energy to jump over this. So generally, you would, according to common sense, think that anything which wants to cross this obstacle either has to go over it or go to the side of it. But quantum particles are too lazy to do that. They tunnel through, so the thing goes on this side and comes out on the other side. And so this is a weird phenomenon of quantum mechanics, but it's been seen in many natural wonders, and the sun uses it too. Well, how? So I said that these two magnets won't, attract each other because they're both repelling, and just like that, two protons in the interior of the sun wouldn't want to attract each other because, well, they're the same charge. But those particles have a probability of quantum tunneling into each other. So this one could just tunnel into this one and then just fuse and form a new nucleus, and form and make more elements for the sun to fuse. And so this is how the sun runs. All of the protons in the sun which are fusing right now have a probability of quantum tunneling into each other and forming a helium nucleus. And that's what happens. All of them quantum tunnel into each other and form a new helium nucleus. So, thinking about it, if the quantum particles didn't have a probability of fusing into each other, then the sun wouldn't shine and the plants won't have photosynthesis, and yeah, you know what happens. So finally, you owe your life and everything you have around here to quantum mechanics and quantum tunneling. So thanks for watching, and I'll see you in the next video.